Okay, my lovelies, the last time we did a PhET lab, which was late last week, you did the moving man distance versus time graph. On this assignment, you closed out the bottom two graphs when you opened up the simulation, and you graphed what the line did as you went from distance versus time. So distance was on the y-axis and time was on the x. Today's PhET lab, you're using the same simulation, but the difference, instead of distance, which is position on the simulation, versus time, now we're looking at velocity versus time. So when you go to the second tab in the simulations where the graphs are, close the acceleration graph. You're going to use the top two. Play around with it, see how it differs. So when you do the graph, this part right here will look like what you did last time. On these graphs, instead of distance versus time, you're going to do velocity versus time. So what you're actually calculating over here, the slope of the line will equal acceleration. Whereas over here, the slope of the line equaled the velocity. Okay? So on this one, the moving man from 0 to 10 at a slow, steady pace. So your line should be something like this. Okay? As he moved from 0 to the 10, so on here, he moved from 0 to 10 on the simulation. He moved at a steady speed over time, so however long it took. This is the same as what you had on the previous, but now we're going to look at velocity versus time. So he went from 0 to 10 at a slow, steady pace. If he didn't speed up and he didn't slow down, it was a steady pace. Okay? So he went at a constant speed. You can pick anywhere on here whatever his constant speed is. At a slow, steady pace. Let's count it as 5. So his velocity stayed the same as he walked from 0 to 10. You get the idea? Here, distance over time, this is your velocity. Because he went a slow, steady pace, steady meaning he did not speed up, did not slow down, your acceleration line is horizontal. So your acceleration would equal 0 because he did not speed up and he did not slow down. So a man moving from 0 to 10 at a fast pace. Okay, it didn't take him as long, so the slope is a lot steeper. It didn't say that he sped up or slowed down. Okay, so if we picked 5 at a slow, steady pace, 10 would be another horizontal line. A fast pace. He didn't speed up, he didn't slow down. Okay. A man standing still at 4 meters. Okay, here he's standing still at 4 meters. Well, if he's standing still, is he accelerating or is he? Well, first of all, if he's standing still, is he moving at all? His velocity is going to be 0. So if you're going to graph velocity over time, if your velocity is 0, then your line for your acceleration should be on the x-axis. Okay? There's the first 3. Now the second, do it just like I did the first 3. This side, distance over time. So these are your velocity graphs like you did last time. These over here are going to be your velocity versus your time graphs. So the line that you're actually graphing is going to be your acceleration. Okay? Go ahead and do those. See if you can do them from what I went over on the front side. When you get to the bottom, don't ignore this part because this part you'll be able to figure out if you got it. So distance versus time, these are your velocity graphs. And then if you take your velocity, put it on the y-axis versus time, okay? And so this is the timeline. This is going to be graphing acceleration. So this first point here, okay, he went from 0 to 3. He went from 0 to 3 meters. And it took him 2 seconds to do it. 2 seconds. So his velocity is 1.5 meters per second for this part right here. Okay. The slope of this line, the rise over the run, the difference in the y-axis divided by the difference in the x-axis, from going from here to here. That's your 1.5 meters per second. You come down here, okay, this 2 seconds here, that's a 2 seconds. This is 1 second. This would be 4, so this would be 3. You get the idea. If this is 5, we're going to make this one cross at 5.5. Okay. So after 1 second, the velocity, his velocity is going to be 1.5 meters per second, and it's going to be the same velocity for 2 seconds. So the first 2 seconds, he's going 1.5, and then he goes another 1.5. So this first line is acceleration. He went from 0 to 3 meters in 2 seconds. That's his acceleration. Okay. His velocity is 1.5. You get the idea. He accelerated from 0 to 1.5 and then another 1.5. This top part, okay, this next part, it's a lot steeper. So here he's going slow, then he sped up because the slope is a lot steeper. So he went from 3 to 10 meters. So the slope or the velocity right here is going to be 7 meters because that's the difference. He went from 3 meters to 7 meters, but he did it in 1 second. So his velocity is 7 meters per second. Okay. Okay. Sorry, got distracted. Here we go. So here to here, the slope was 1.5 meters per second. Okay. Here to here, your velocity is now 7 meters per second. So the difference between this and this, so the velocity is now 7 meters per second, is up here at 3 seconds. Okay. If we take the slope of this line, that will give us our acceleration. Okay. The slope of this line. In this case, here you have 7 meters, the final, minus the 1.5, and it took 1 second. Started at 2 seconds, went to 3. So over the span of 1 second, he went from 1.5 meters per second to 7 meters per second. So 5.5. The slope of this line should be 5.5 meters per second squared because it's acceleration. Okay? And then the person stood still. Okay? He didn't go anywhere. The distance didn't move. So he didn't go anywhere. He's standing still. If you're standing still, think about this and do this next section. If he's standing still, he's not accelerating, he's not moving. What is your velocity going to be? 0. If your velocity is 0, what is your acceleration going to be? Think about it. Okay? Velocity is 0. Can you be speeding up or slowing down? Take it from here and try to do the rest. And let me see what you come up with. Okay? So you're tracing, you're figuring out what the velocities are, and you're graphing the velocities versus time. How is the velocity changing every time he changes what he does up here? Okay? Clear as mud. Let's see what you come up with. Okay, this is going to be due Wednesday. So get them all turned in by Wednesday. Thanks a lot.